Hello, everyone.
Hi.
Let's go ahead and get started on 4.3. We're talking about congruent triangles. Let's start filling in our notes. Oh, goodness, where'd my pen go? Here it is. Okay. Triangles that have the same size and same shape are called congruent triangles. Congruent because congruent means?
Same size, same shape.
Yeah, same size, same shape. So two triangles that have the same size and the same shape are called congruent triangles. Two triangles are congruent if and only if all three pairs of corresponding angles and all three pairs of corresponding sides are congruent. Now we have this phrase, if and only if, in this sentence. And this phrase, if and only if, means, spell it right, if and only if. This phrase means that both your original conditional statements, in this case, if two triangles are congruent, then all three pairs of angles and all three pairs of sides are congruent. It means that and its converse, if all three pairs of angles and all three pairs of sides are congruent, then two triangles are congruent. Both of those statements are true. You can go in either direction the moment we include an if and only if. We can extend this to any polygon, not just triangles. So any shape that's all closed up and has all straight sides is considered a polygon. And so if two polygons are congruent, then all of their corresponding parts are congruent. Sorry for writing ugly. Now we're going to be working on proofs again. We have one in our examples today. We have another two-column proof. And we're going to be proving that triangles and other shapes are congruent to other triangles and other shapes. In order to show that triangles are congruent to each other, we have to show that their corresponding parts are congruent. And so the reason, when we finally get all that done, we've shown all the sides and all the angles are congruent, then we state the triangles are congruent. The reason for those triangles are congruent would be corresponding parts of congruent triangles are congruent. All of that. Now, so far this year, anytime we've done a proof, I've been like, don't abbreviate. Write the whole name for everything, all of it. And you guys are going, oh my God, right? And this is a reason, which means you have to write all of that. Every single, yeah, mathematicians got lazy at this point too, and they said, we're abbreviating this one. And so this will be the one and only one that, please, for the love of God, abbreviate. It's too long for me to read. It's too long for you to write. CPCTC, corresponding parts of congruent triangles are congruent. Okay? Abbreviate that one. Corresponding parts of congruent triangles are congruent. CPCTC. Now, we've made a lot of mention about corresponding parts, but haven't stated what those are. Corresponding parts of any polygon would be if I had two polygons and I cut them out and I laid them over each other, the parts that matched perfectly would be the parts that correspond. If we're talking about people, my left hand would correspond with your left hand. My right hand would correspond with your right hand. I shouldn't put my foot on your hand and say those are corresponding parts, because one's a hand and one's a foot, right? We do the same idea with polygons. We're going to practice on these triangles that I have here, and I'm going to color code. So if you have your rainbow of markers as I do, bust them out now. There's some shuffling to bust out all the colored markers. I'm happy. All right. I'm going to bust. If you don't, then just Write whatever you need to write to help you remember what things, markings mean what. And then you can borrow my rainbow later. Okay, so here we go. On this angle B, I have one marking. That means everywhere else in my picture that's related to that triangle, any angle that has one marking is congruent, which means B is congruent to J, and angle B corresponds to angle J. Angle A has 2 arcs. Angle H has 2 arcs, which means that angle A corresponds to angle H. They're congruent. Angle C has 3 marks. Angle K has 2 marks. Angle C and angle K are congruent. They're corresponding. If I were to cut these little figures out with my scissors and lay one on top of the other, allowing for me to spin it around or flip it over to get it to match up, we would find that angle C would line up perfectly with angle K. Okay? That's how they correspond. We can also have corresponding sides. The one little mark in there means that that segment from point A to point B is congruent to this other segment that has 1 mark. That is the segment from point H to point J. And so these segments are congruent. Here's another pair of congruent segments, B to C and JK. And we have this pair of segments, AC to HK. Now, when we write our congruent statement, we write that one triangle is congruent to the other triangle. I have said in the past, it doesn't matter what order you write the letters in, right? Just name the triangle, put it in the order, we're happy. But when we write that one triangle is congruent to another triangle, the order between the names of the 2 triangles matters. In this congruent statement, A is listed first, then B, then C, which means in my other triangle, I have to write them in that same order of corresponding parts. A corresponds to H. A was written first. H must be written first. B was written next. B corresponds to J. J must be written next. C was written next. C corresponds to K. K must be written next. Let's look at the invalid statement and see what happens. Again, I have A, B, and C, but when I go to the triangle it's congruent to, I have H corresponding to A, that's okay, but the next letter is K. K corresponds to C. In my first triangle, I didn't have C next, I had B next. This is not a valid congruent statement. This is like saying my hand to her head. My hand does not correspond to her head. That's weird. Okay? That's basically what happened right here. Bless you.
Thank you.
Let's go to our practice problems. We're going to do the top 4 first, and then we'll come back and we'll pick up the third angles theorem in just a moment. Example number 1 says identify all of the congruent corresponding parts and then write our congruent statement. That congruent statement is triangle congruent to triangle. We're going to write everything that's congruent down and then the final one at the end. All right, I'm going to color code, okay, so that we can see which lines are congruent to which and which angles are congruent to which. I've marked down all the angles that have 1 arc in them. Those are all congruent to each other. In orange, I've colored all the angles that have 2 arcs in them. Those are all congruent to each other. In yellow, I've colored all the angles that have 3 marks in them. Those are all congruent to each other. In green, I've marked all the segments with 1 line through them. Those are all congruent to each other. In blue, we have all the segments with 2 lines through them. Those are all congruent to each other. And in purple, all the segments that have 3 marks through them. Those are all congruent to each other. Let's write the congruent statement for all of the different pieces to identify exactly which pieces are congruent to which. And then we'll write the final congruent statement for these 2 triangles being congruent. All right, matching up the colors. Looking at angle A, which is marked with pink. Angle A is congruent to
J.
J, because that's the other one that has 1 arc colored in pink. Give me another angle congruent statement.
B is congruent to J.
Okay, clarify, make sure that you say angle B is congruent to angle K. Otherwise, what geometers, is that a word? People who do geometry are going to think you mean point B congruent to point K, which makes no sense because congruent means same size, same shape. And a point, if we call, it has no size and no shape. Thank you for remembering from day 1. So we can't talk about points being congruent. No size, no shape. Nicely done. All right, last angle.
Angle C is congruent to angle L.
Gorgeous. Let's do the segments. Again, make sure you say segments and you list 2 points where the segment starts, where the segment stops. Those are the sides of our polygon, of our triangle. What else? No, I think that was it. Okay. Segments, go.
Segment AB,
Line segment AB.
congruent to JK. Segment, line segment JK.
Line segment AB is congruent to line segment JK. Nice catch. Next pair of segments.
Line segment BC is congruent to line segment KL.
Gorgeous. And the last pair? Preferably someone who has
AC is congruent to line segment JL.
lovely work. Now we're going to write that the triangles are congruent to each other. We have stated that all 3 pairs of angles are congruent and all 3 pairs of sides are congruent by CPCTC. Corresponding parts of congruent triangles are congruent. We can state that these 2 triangles are congruent. Remember that order is important between the triangles. I'm going to write the first triangle. Decide which one you want to be the first triangle, and then put the vertices in any order you like. Go.
Triangle ABC.
Triangle ABC. Alphabetical order works for me. It is congruent to, now you have to be careful.
JK.
Put them in the same corresponding order. A corresponds to J. Next he chose B. B corresponds with,
K.
and last he chose C, which corresponds to,
L.
and that is our final congruent statement.
Legit, miss, I don't understand. They're gonna send it to. Oh, we got the black eye. I ran into the door.
I'm sorry. We're on our second page of notes. Let's go ahead and continue. Thank you so much, ladies. We're looking at number 2. Take a moment to digest what all of those symbols mean. I'm going to color code to help your eyes track what each thing is doing, okay? I hear pens clattering, which tells me that I've got a couple people in the room that are rainbow skittle throw up on their papers too. Remember, when you are doing homework, working on quizzes or on tests, if you want to do this to your figure, that is completely 100% encouraged and supported by myself and everyone else in the room. If the coloring helps you and makes it easier for you to see it, color it. All right. List out what are our congruent pairs. Go.
Angle A is congruent to angle B.
Angle C is congruent to angle B.
All right, I'm going to pause you right there. You are not wrong. Angle C is congruent to angle B. But there's 3 angles sitting at each vertex C and B. You have the one colored orange, the one colored yellow, and then the one big one that's composed of the orange and the yellow one smashed together.
Say angle ACB.
So we'll say angle ACB if you mean the angle that I have colored in yellow, the one that has 3 markings. Angle ACB is congruent to
Angle DBC.
You said DBC, you said CBD, you were both correct. The corresponding parts having to match up with the names only is important when you're talking about the entire shape. We're talking about just the angle that's colored in yellow with the 3 markings. The angle that's colored in yellow is congruent to the other angle that I've colored in yellow.
So why didn't you just put ABC?
Because I have this angle that's at C, and I have this angle that's at C, and I have this angle that's at C. And unless you tell me where the sides are of my angle, I don't know which C or which B you're talking about. Okay? And so we're just being really specific. You're not wrong. It is the angle with vertex at C and the angle of vertex at B. We just have to be really specific about which one we're talking about. All right, and then the last pair of angles.
Last time?
Yeah, we need 3 pairs of angles congruent. We did the one with 1 marking. We just did the one with 3 markings.
So BCD, angle BCD.
BCD, so he's looking at this orange one. Congruent to
Angle CBA.
angle CBA or ABC, that works too.
But we haven't got the big one yet.
You're right, we haven't talked about the big one. Right now we're talking about triangles congruent to each other, so we're looking at that shape as 2 different triangles. Yes, they share a side, and they're kind of looks like they're stuck together, but we're looking at them as 2 separate triangles. Speaking of sides being stuck together, looking at that purple side, line segment BC is congruent to what segment? What's the other one there that has 3 markings on it? Yeah, itself. Which you could write as CB because that's just another name for that line segment.
Would that be the reflexive?
It's a property. It's a reflexive property. Hang on to that little nugget. Write it for yourself somewhere right here. Because when we get to the bottom of the page and we look at the proof, that's going to show up. Okay. What other segments are congruent?
AB, segment AB is congruent to segment BD.
And?
Line segment BD is congruent to line segment AC.
Line segment
BD.
OBD
Wait,
is congruent to line segment AC. Wait, what did I mess up?
yeah, no.
This
That's
one?
wrong. That's wrong.
Line segment AB is congruent to line segment CBD.
Okay. I must have misheard. I'm very sorry for writing wrong. Thank you for double checking to make sure I wrote it right and calling me on it and making sure that I did it properly. Thank you very much. Now let's write the 2 triangles that are congruent. Remember, again, the order between the names of the triangles is important. Whatever order you write the first one in, you have to write the other one in the same order for those corresponding parts. But you get to choose which triangle you want to name first. It doesn't matter which one you pick first. And it doesn't matter what order you write the vertices in on the first triangle. All right, someone give me the name of the first triangle. ABC. Once again, we have alphabetical order happening. That's okay. I tend to like doing funny things like trying to make words. So I like naming these triangles CAB because I can go triangle cab. It's okay. Alphabetical order is just fine. We have triangle ABC congruent to? Okay. First off, I have to write the symbol for triangle, right? Okay, so A corresponds to D. B corresponds to C. and C corresponds to,
Oh, okay.
yeah, this thing has a flip happening. It has been reflected
Reflected.
somehow. Huh? All right, let's look at number 3 and 4. There's some algebra involved, but it's got the same underlying concept. Suppose these two triangles over here, ABC and DEF, are congruent to each other. This means that point A and angle at A is corresponding with D, B is corresponding with E, and C is corresponding with F. Looking at our figures, that means that this angle corresponds to this angle. And this angle at B corresponds to this angle at E. And this angle at C corresponds to this angle at F. Using our concept of corresponding parts being congruent, if C measured 40 degrees, what would be the measurement at angle F? 40 degrees, because they have to be the same size. We're going to use that concept to solve for x and y. I'm going to look at y first. This expression here has only y's. This one here has an x, so I'm going to deal with it last. I'm going to go figure out what y is first. All right, so here's the expression with y. This is the measurement of angle D. What angle corresponds to angle D?
Angle A.
Angle A. And since corresponding angles are congruent,
He said it.
we're going to set them equal to each other. The measure of angle D is equal to the measure of angle A. That is the 2y minus 5, which is the measure of angle D, is equal to 65, the measure of angle A. And now I can solve for y. You have a 5-second head start. Go.
30.
It-
No. 35.
35? Which means up here I can replace the y with a 35, and suddenly that expression looks a whole lot easier to deal with. This expression, 2x plus y, which is 35, is the measurement of this side of my triangle E to F. It is congruent to BC. BC. It corresponds to side BC, which means it is congruent to BC because the triangles are congruent, which means those measurements are equal. The measurement from E to F is equal to the measurement from B to C, which means 2x plus 35, the measurement of EF, is equal to 90.6, the measurement of BC. Solve for x. I'm going to need your help with this, guys, because I can't do the decimals. X is 27.8. Okay, talk to me about how you did that. He mashed buttons on his calculator. Fabulous. What's the first step that you did?
Minus 35 to
Okay, so you subtracted 35 from his 5, and when you did that, you got
55.6.
55.6, and then
I divided by 2.
you divide it by 2, and we ended with 27.8. All right. Did we do what we were asked to do?
Yes.
We are awesome. Take 5 seconds to summarize this corresponding parts thing in any way you need it to be written. Put it somewhere on this paper, the front and the back, or wherever it makes the best sense for you. And then meet me on the bottom of page 1 for third angle theorem. You've got 10 seconds to summarize for yourself. Go. All right, we're going to go ahead and look at the third angle theorem now. That's the bottom of our first page of notes. The third angle theorem says this. if two angles of one triangle are congruent to two angles of a second triangle, then the remaining third angles of the two triangles are congruent to each other. This is what's happening. I have a couple triangles hanging out. They're just chilling. And I know that on this first triangle, two of its angles are congruent to two angles on the other triangle. So this angle is congruent to that angle, and this angle is congruent to this angle. It doesn't matter if when you do them, they don't look congruent. I put the marking so they're totally congruent. This theorem says that whenever I have a setup that looks like this, I can automatically state that this remaining angle that I know nothing about, they're congruent to each other. Do you want to know why? Because each angle adds up to 180. And if I already know the measures of these two are the same as these two, let's say added together they equal 100. Well, if these two added together equal 100, what's the measure of this one? And if these two are the same thing, then what's the measure of this one? They're congruent. We just did the proof. That'd be a perfect paragraph proof if you were asked to write a paragraph proof for this. You're welcome. Let's look, speaking of proofs, let's look at this two-column proof that's in the bottom of page 2 of our notes as an example. Partially filled out for us. Let's dig in to see what they did and fill it in. Looking at the given statement, here's our diagram. We're told that line segment AB is congruent to line segment CB. So I'm going to take my writing utensil and I'm going to update my figure with some auxiliary lines to show myself those things are congruent. The next thing I see is that AD is congruent to CD. AD congruent to CD. I'm told that angle BAD, this one right here, is congruent to angle BCD, this one right here. And then I'm told that line segment BD bisects angle ABC, the angle that I drew that is colored green right now. That angle got bisected. What did bisect mean? To cut in half evenly. Which means the angle over here on this side of BD is going to be the same size as the angle down here on the other side of BD. That could come into importance in the proof. This statement doesn't say those two angles are congruent. This statement says that that line BD cut this big angle, and that's going to create two angles that are congruent. We've just got to find a reason to state that those two angles that were created are congruent. And it has to do with the meaning of this word. That's going to come up in about 30 seconds. Let's get into the proof. First statement in the proof is always the do we have any part of the given already written down for us anywhere else in the proof?
Yes.
Where? Statement number 3 has, bless you, angle BAD is congruent to angle BCD. So the reason for that is that it was given, and I no longer have to write in my first line the statement I highlighted in pink, because it's already been written for us somewhere else in the proof. If you don't want to put it somewhere else in the proof, you can totally put it at the top line. That's okay. Which means everything else in the given I have to write in the first statement line. All right, it's a race. Who can fill that in first? Go. Oh God, it's under so much pressure. I'm writing the wrong letters. You're done? You won? Oh, I'm so slow. And I had to write it really small. Sorry, guys. Oh, my projector's crazy. There you go. Sorry. All right. We're good so far? Awesome. All right, the next statement says line segment BD is congruent to line segment BD. It's congruent to itself. Which one?
Reflexive.
The reflexive property. You're exactly right. So the reason that we're stating that that segment is congruent to itself is the reflexive property. Please put of congruence, because we're dealing with congruence. The fourth reason says definition of angle bisector. What did angle bisector mean again? The thing that cuts an angle into two equal pieces. Remember back to that given statement. BD cut angle ABC, which meant that this angle up here was congruent to this angle down here. We explored that already. We just have to find a way to state those specific angles, the ones in orange, not any other angles with vertex B. This side and this side. Name that angle. CBD is an appropriate name for that angle. Name this other angle in orange. Angle DBA? Is that what you said? Yes. Okay. That is also an appropriate name for that angle. Lovely. Now the next statement says that this angle right here, BDA, is congruent to this angle right here, BDC. We're wanting to show these triangles are congruent, right? The triangle that's above line BD and the triangle that's below line BD. In order to show triangles are congruent, we have to show that all the different pieces of them are congruent to each other. All the pairs of sides are congruent and all the pairs of angles are congruent to each other. Before I colored in the yellow, we had all the sides. We needed the yellow to complete all three pairs of angles. We had two pairs of angles. We needed the third pair of angles. That sounds super familiar. The third angle theorem, the reason it's written up there. The third angle theorem says if two angles of one triangle are congruent to two angles of a second, that's what I had leading into this statement, then the third angles of the triangles are congruent. Those third angles which I needed in order to state that the two triangles are congruent by corresponding parts of congruent triangles are congruent. How are we feeling on this right now? Good? Awesome sauce. That's all I had for you today. Thank you very much.